Okay, I wanted to do 4 representative problems from the worksheet I gave out yesterday, just because I had several questions on these. And so here's a video that will help explain the logic behind them. Whether or not you got them correct, it's just good to listen to how to think these things through. So number 11, imagine you're hovering next to the space shuttle at an Earth orbit and your buddy of equal mass, who is moving at 4 kilometers per hour with respect to the ship, bumps into you. If he holds on to you, how fast do you both move with respect to the ship? So at its heart, this is an inelastic collision. You have object A, your buddy, is going to collide into you. And notice that you don't give a mass, so I'm just going to call this mass M and mass M because you're equal. We don't know what M happens to be. Just for right now, I'm going to call the velocity of your buddy V. It's 4 kilometers per hour, but let's just call it V for right now just to see what happens in this problem. So conservation of momentum in an inelastic collision says that MAVA plus MBVB has to equal, now if you stick together, it's going to be MA plus MB, and then you both travel together. And so this is how you always set up a conservation of momentum when it's an inelastic collision, when things stick together. So, so now let's take a look at the way this thing is going to sort of unfold here. Now, both you and your buddy have the same mass, so we don't have to distinguish between A and B. So I'm just going to cross that off for a second. And you started at rest, so this whole term is going to go to 0, right? That whole term goes away because you're just sitting there at rest. So the whole momentum of the system is really your buddy. So MVA has to equal, now M plus M, remember you have equal mass, so this is really just 2M VF. Because again, you both travel at the same velocity if you're stuck together. So you're trying to figure out, this question says, what is the final velocity? Well, let's just solve for it. It's going to be MVA all over 2M, and that has to equal VF. Notice that the mass is totally irrelevant because you and your buddy have the same mass, and so it's just really 1/2 of whatever the original velocity of your buddy was, that's what you're going to be. And now you can see that 1/2 of 4 is 2. So it's going to be 2 kilometers per hour. All right, that's the longer way to do it. The easier way to do it is to just think about this thing logically. You don't even have to write any of this down if you're pretty good at physics. You can say that all of the momentum of this system is, I'm going to switch to a different color. All the momentum of the system is your buddy, okay? And you and your buddy have equal mass. So if you're doubling the mass of the system, then you have to have the mass, if you're doubling the mass of the system, then you have to have the velocity of the system in order to keep things conserved, right? In order to keep things consistent. So you could have just looked at, okay, so if we're doubling the mass, then the final velocity has to be half what it was, and it was at 4, so now it's at 2. So that is another way you could have done this thing logically. My wife is asking me for 20 more sheets to put in the printer, so she's going to have to wait till I'm done the video. Sorry, honey. So comic strip hero Superman meets an asteroid in outer space and hurls it at hurls it at 100 meters per second. The asteroid is 1,000 times more massive than Superman is. What should his recoil speed be? Okay, assume that they're both at rest. So I always just call the objects A and B. Well, not always, but just to make things faster. Notice that you're both at rest initially. So the initial momentum of the system is 0. That initial momentum of the system has to be equal to the final momentum of the system, and the final momentum of the system is going to be the mass of object A, which is we'll call Superman, times the velocity of A plus mass of this asteroid times the velocity of the asteroid. Right? Because again, you were both rest, so your initial momentum has to be 0 because your velocity was 0. That's just where it comes from. So notice that they don't give you the actual mass. It just says that the asteroid is 1,000 times more massive than Superman. So whatever Superman is, let's call it M. So M, so 0 has to equal, now mass of Superman will be M, and we're trying to figure out what his velocity is. We'll just call it VF. We don't know what the mass specifically of the asteroid is, but it's 1,000 M. Whatever Superman is, it's 1,000 times that. And we know that this thing is going to be at 100. So this is how we're going to do this problem, that if you think about this now, that negative mvf divided by 1,000 m equals 100. I'm just solving this thing now. The m's will go away. Actually, you know what? I guess I didn't even have to divide by 1,000. Because guess what? I'm just going to multiply it back over here again. So yeah, sorry, a little brain fart there. I didn't really have to divide by 1,000. So the final velocity is going to be negative, looks like 100,000. Yeah. So looks 100, yeah, 100 times 1,000. So the velocity of Superman is negative 100,000. Now, if that sounds super fast to you, that's because the whole point of this problem is to show you that the cartoons are super unrealistic. Yeah, surprise, surprise. That if Superman was to hurl an asteroid, he would be flying backwards at incredibly high speeds. But that's how you would do that one. All right, these last two are conceptual questions. Here you have a truck colliding with a stationary car. And the truck is much bigger. So, big truck. Which experiences a larger force? So these are all conceptual. Well, they can be solved conceptually. When the two objects crash, there's a force of the truck on the car and the force of the car on the truck. Newton's law says that those are equal. So neither has a larger force. Again, the forces are equal and opposite. Which has a larger impulse? Impulse is Ft. We've already said that the force is the same. If two things collide, their contact time has to be the same too, right? It's not like, one object is going to collide longer than the other object. They have to have the same collision time. So this is the same F, the same T. They have the same impulse. By definition, impulse is a change in momentum, so they have the same change in momentum. Which one experiences a larger change in velocity? Now, you could calculate this one out if you wanted to. It's not that hard to do. It would be 4,000 times 10 plus 0. That's the initial momentum. Has to equal, now they're going to stick together. Wait, are we? Oh, yeah, so we'll imagine this is an inelastic collision. Oh, sorry, we'll imagine this is an elastic collision. So this will be 4,000. Oops, sorry. I just had a brain fart there, and then I think my wife just walked in and asked, well, how come I didn't change the paper in the printer? So this would be 4,000 plus 1,000 times VF. And now you can solve VF. If you solve this thing out, the truck goes from 10 meters per second to 8. And the car, which was at rest, goes from 0 to 8. So which one has a larger change in velocity? The car. All right. Another way you could have just done this one conceptually is if you have a certain amount of change in momentum, a really big mass will have a lower change in velocity. A really small mass will have a higher change in velocity. Which one has a smaller mass? The car. So that's one way you could just quickly do it without even having to calculate. 14. And incidentally, this would also hold true for an elastic collision, not just an inelastic collision. 14. 1,000 kilogram car increases speed from 5 to 10 meters per second over 1 second. Separately, a bigger car or bigger truck increases speed from 5 to 10 over the course of the same second. So notice they have the same velocity increase and the same time interval. The only difference here is going to be their mass. So which one experiences a larger force? F equals ma. They both have the same acceleration. But different masses, so the heavier car has to have a bigger force, right? Because it has the same acceleration, but it's a heavier mass, so you better have a bigger force accelerating it. Which one has a larger impulse? Ft. They both have the same time interval. The truck has a greater force, so truck. Boom! Which one has a larger change in momentum? Well, if you've already said the truck has a larger impulse, then by definition the truck has a larger change in momentum because they are the same thing, right? It's the same thing. Which one has a larger change in velocity? Well, they both went from 5 to 10, so neither. So that is how we do those problems.